Solve the following system of equations. If there is a single solution, answer it as an ordered pair. If there are infinitely many solutions, parameterize your solutions in the form of a point x, f of x. Answer using reduced fractions if necessary. Okay, so in this particular equation set, I have two linear equations, and therefore I have two equations with two variables. So the method that I want to use to solve this is elimination. That's usually the easiest if you have two equations and two variables. If you've got nonlinear equations, the substitution method works well. And if you have larger linear systems, then the Gauss-Jordan is a good method to go with. The object of the elimination method is to multiply one or both equations by a constant so that when you add the two equations together, a variable drops out. In this case, I'm already set up because negative 2x plus 2x would cancel. So let's just go ahead and do that. So negative 2x plus 2x, those cancel each other out and leave me 0. Positive 3y and negative 3y do the same, so that results in 0. Then negative 25 plus 25 also results in 0. So here's a problem. We have everything canceled out. Now, this is not a contradiction. 0 is in fact equal to 0. But what's happening is we have two lines that are mapping the exact same set of points. So they're effectively intersecting at every single xy coordinate pair that exists. So how do we express that? The way that we express that is by parameterizing our solutions. And it's a fairly straightforward process. What we do is we take one equation and we write it as f of x. So write negative 2x plus 3y equals negative 25 as f of x. All right, so what that means is we solve it for y. So 3y equals 2x minus 25, and all I did there is add 2x to both sides. Now to get y by itself, I divide both sides by 3. So y equals, you can leave it in this form right here, or you can go ahead and divide the 3 into both parts. It doesn't really matter. But make sure both terms in the numerator get divided by the 3. And then that is equal to a function f of x. So when I give my solution, the solution is of the form x comma f of x. So my solution I'll write as x, and x is known as a free variable, so you can pick whatever you want for x. But when you choose something for x, you put that value into the equation 2/3 x minus 25/3 in order to come up with a solution pair xy that solves the system. And this will work for any value of x that you choose. So for instance, if you chose 3, all right, just using 3 because well, actually that won't cancel that out. Possibly 1. Okay, so if I chose 1 for my x value, then 2/3 times 1 would be 2/3 minus 25/3. And that would be, let's see, 2 minus 25 is negative 23. So that gives me an xy coordinate pair. And if I put that coordinate pair into either line equation, it will solve both of those line equations simultaneously. So just to show you, if I plug it into the first equation, it's negative 2 times 1 plus 3 times negative 23 over 3, and that's supposed to be equal to negative 25. So this would be negative 2, these 3 cancels, Minus 23 then is what's left in this part. Negative 2 minus 23 is in fact equal to negative 25, so it solves that value. If I plug it into the other, it's 2 times 1 minus 3 times negative 23 over 3 equals, this time, positive 25. So let's see if this works. So this would be 2 minus 3's cancel, and minus negative 23 is the same thing as plus 23. And 2 plus 23 is, in fact, 25. Now, this clearly doesn't prove that this system solves for every single coordinate pair, but possibly it will give you the intuition as to why it could, okay? But this is why we go about describing our answer in this form, because this maps out the line, the same line that these two equations do as well.